Okay, so let's think about the factorial function. So what do we know? Well, we know factorial, as we write it, factorial n. What does it mean? It's basically 1 times 2 times 3 all the way up to the value n. So if we did something like factorial 1, obviously the answer is 1. If we do factorial 2, it's 1 times 2. Obvious. If we do factorial 3, what is it? It's 1 times 2 times 3. So notice as you're making this progression to work out these factorials, you're always looking at what the previous factorial was and just adding one more to it, timesing by a higher number. So if we could calculate 1 factorial, we just need to times that by 2, and that would get me 2 factorial. If I could work out 2 factorial, I'd just multiply it by 3, and that would give me 3 factorial. So if you think about 4 factorial, it's 1 times 2 times 3 times 4, which is 1 times 2 times 3. Well, we know that's 3 factorial times 4. So straight away we've got a progression there. We can see that if we could calculate a particular factorial, we just need to multiply it by another number, the next number in the sequence, and we get the next one. So what we've got here is a sequence going 1, 2, 3, 4, and we're always using the value before. So what construction have we got in Python which would allow me to go from 1, 2, 3 all the way up to a particular number? Well, obviously we've got the for loop construction. So I've got some way of looping round in a particular loop, and as I loop round that loop I can take a variable, let's call it n, and that can be in the range 1, 2, 3, 4 all the way up to some particular number. So think what we want to do in here now. What we want to do is take whatever we had at the previous step. So if we're imagining 4 factorial, I'd want to take what I've calculated in 3 factorial in here and multiply it by 4. If I was calculating 3 factorial, what would I do? I'd calculate 1 times 2, which is 2 factorial, and then multiply it by 3. If I was calculating 2 factorial, what would I do? I'd take 1 factorial and multiply it by 2. And going back, if I took 1 factorial, what would I do? Well, that would just be 1 times 1. So I need a value to start with. So my answer that I'm going to try and calculate needs to start outside of the loop with a value of 1. So I'm going to create a variable called answer equals 1. And each time around the loop, what did I say? I'm going to take my current value of answer, I'm going to multiply it by my loop variable 1, 2, 3 and 4. So that's my n, and that's going to give me my current answer for the current position. So just trying to work around my logic here. I set answer to 1, I come into my loop, answer equals answer times n, well, n is 1, so 1 times 1 is 1, so initially my answer is 1. I go around the loop again, now the answer is 1, I multiply it by n, which is 2, so I now get the answer 1 times 2. Go around again, the answer is, the number is 3, come around here, so it's going to be 2 times 3, that's going to give me 6, which is 3 factorial. So answer is 6, I go around the loop, now I get 6 times a new value n, which is 4, 6 4s are 24, that's 4 factorial. And I keep doing that all the way up to whatever predetermined number I want, the value num. So this function at the end should return the variable answer with the factorial in there. So we've thought about what we're trying to construct, we've looked at the maths, we've made sure we understand the problem, we've kind of broken it down into several steps, we've analysed each step, we've then thought about the code that seems to work for that, which is our for loop, we've come up with an idea, we've worked it out, we're pretty logical, we think that's right, so we've now got a code design here to actually work with. So let's go on and see if we can write the code to make that happen. Okay, so here's our factorial function. We're passing in a number. Let's just have a look what we said in our code. If you refer back to our plan, we said we were going to create a variable called answer, which initially we're going to set to the value of 1. We then want to go into our for loop. Going to use a variable n for that. So variable n in range 1 up to whatever particular number they're asking me to calculate. That's my for loop. And in here I want to do answer is assign the value answer times n. So there's our loop going round here up to the particular number I'm calculating number of times, and we're multiplying answer by that each way. So answer should be our factorial. We fall out the loop here because there's no more indentation, and here we just return the variable answer, and that's our factorial value. Okay, so we don't need to mess about with main now because we know that works. We've tested it. We haven't messed with this prime. We know that's not working properly yet, but it's just returning true. Let's see what our factorial does. I'm going to run our module, resave it. Let's bring that up to the top of the screen so you can see what's going on. Factorial and prime number checker. I'm just going to put 5 in there as a starting number, and there we go. So it's done 2 and returned 1, 3 and returned 2, 4 and returned 6, 5 and returned 24. So is that right? Well, clearly not. There's been a bit of a mistake here because the number 2 should be returning me a factorial 2. The number 3 is 1 times 2 times 3. That's returning me a factorial 6. The number 4 should be 1 times 2 times 3 times 4. So that's returning a value 24. So we think our logic has worked, but clearly something's gone slightly wrong in the way that we've calculated this. So what we need to do now is have a little think about our program to see if we can work out why it's done it. It's clearly doing the right kind of idea because our sequence here is going up, but it looks like somehow we're out by a single step, and clearly what we need to do is work out how to analyze that. Okay, so here we are back in our code. It didn't quite work as we expected. So remember, looking at our output, when we got the value 2 it generated an answer 1, when we got the value 3 it generated 2. So it kind of seemed to be one out of step. So we just kind of need to do a bit of a code walkthrough here in the initial instance, see if we can spot what the problem is. So up here, when we're in our loop, we generated the value num initially being 2. We called the factorial, so we passed in a value 2. We came down to here, so num had a value 2, and we went round our loop. So we set answer to 1. Initially our value of n was 1, so that's the start of our loop, and we did 1 times n, which is 1, and it gave me the answer 1. We then, remembering that the value we passed in was 2 here, we now go around our loop again, and number was 2. But remember, our for loop doesn't go all the way up to 2, so it wouldn't have gone round this loop a second time to get to the value 2. Remember, it always stops 1 before this value. So even though we had the value 2 in here, the loop never got to that, and that's what I needed. So just like we've done on the for loop up in main, clearly we need to add 1 to this because we actually need it to get to our particular value num. Okay, so that seems to be quite straightforward. Let's run that and see if that solved our problem. So enter our max value to check. We'll go for 6 this time. And yep, here we go. 2 gave me a value 2. 3. 1 times 2 times 3 is 6. 4. 1 times 2 times 3 times 4 is 24. And obviously you can see you're just doing 5 times 4 factorial. So 24 times 5 is 120. 120 times 6 is 600. 268, 2612, indeed 720. So that seems to have worked. We've got our prime number generator working. Out of interest, let's kind of stress it a bit. Let's rerun our code and go up to maybe the value 20. This is obviously going to go quite a long way. Wow! There you go. So 10 factorial is indeed 3,628,800. And you can see that it's calculating these numbers quite big, and gosh, it flew by. Think how many times it's doing these calculations. So it's obviously quite powerful. So our prime number generator seems to be working. I must admit, if we were testing this thoroughly, I'd be actually checking the mathematical computation of these and making sure these values were indeed correct. But for now I'm going to assume that they are correct. Excellent, so that's the factorial part of the program done. Obviously the next thing is to think about the prime number part.